Second question, I am marking question number 2. Let's read this question. 6 parallel forces of magnitudes 1000 Newton, 1500 Newton, 1800 Newton, 2000 Newton, 2400 Newton and 2700 Newton are acting at 1 meter, 3 meter, 5 meter, 7 meter and 8 meter from 1000 Newton force. Full stop. Forces first, third and fifth are acting upwards. First, third and fifth are acting upwards while others are acting downwards. Full stop. Find the resultant force analytically. Whatever methods we are using here, they are all analytical methods. So with the data given, whatever is given in this question, I will write the data first. Here in this question, they had given us 6 forces. First force is 1000 Newton. Second one 1500. Third is 1800. Fourth force 2000 Newton. Fifth 2400 Newton. And sixth 2700 Newton. Out of these forces given, they have mentioned that first, third, fifth, they are acting upwards. So I have marked 10,000 Newton. This will be upward, 1800 Newton and 2400. So first force is upward, third force is upward and fifth force is upward. Remaining all forces, they would be acting downward. Then they had even provided the distances, and distances are from 1000 Newton force. So first I will be marking 1000 Newton force. 1000 Newton force as given in the question, it will be acting upward. So I'll mark 1000 Newton first. Acting upward. Now the distances are given. Between 1000 Newton and 1500 Newton, the distance is 1 meter. Thousand Newton is acting upward, 1500 Newton is acting downward. Then 1800 Newton is upward, located at 3 meter from 1000 Newton. So it is at 3 meter from 1000 Newton. We know that 1000 Newton and 1500 Newton, they are 1 meter apart, and the distance of 1800 Newton is 3 meters from 1000. So the remaining this becomes 2 meter. I hope you all are getting this. 1800 Newton is also acting upward. Then the next distance is 5 meters. 5 meters is the location of 2000 Newton force. So after 3 meter, I will take another 2 meter. And that is, I have marked 1000, 1500, 1800, 2000 Newton. This will be acting downward because it is mentioned in the question. 5 meter distance have been covered. Now the distance between, we have located up to 2000 Newton. Distance between 2000 Newton and 2400 Newton, that is 7 meters. So already 5 meters are there. You can take another 2 meter, that will give you 7 meters from 1000 Newton force. That becomes 7 meter and it is 2400 Newton acting upward. Now what is left? 2700 Newton, that is located at 8 meter from 1000 Newton. So already 7 meters distance we have. The next is this 1 meter and the total distance becomes 8 meter. 2700 would be acting downward. So here I have located the parallel force system as per the directions given in the question. They had also told us the question to find the resultant force analytically. To find the resultant force analytically. Whatever methods we are doing, these are all analytical methods. So here I have to calculate the resultant. I will be finding the resultant, its magnitude, its direction and location. Solution. Since again in this figure we don't have any horizontal forces, I will write that since no horizontal forces are present in the given force system, therefore resultant capital R is equal to sum of all vertical forces. Hence capital R is equal to summation of Fy. So we would be writing capital R as summation of Fy. Upward forces we would consider as positive, downward forces we will take them as negative. Hence resultant capital R is equal to 1000 Newton is upward, so 1000, 1500 is downward, minus 1500, 1800 is acting upward, plus 1800, 2000 is acting downward, minus 2000, 2400 upward, plus 2400, 2700 Newton downward, so negative. If I add all these values, if I calculate this, I will be getting my answer of resultant, which comes out to be 1000 Newton, and the answer is negative, or you can say 1000 Newton with the direction as downward. This is my first answer, where I am getting resultant value as 1000 Newton and the answer is negative. It means resultant will be acting in the downward direction. After this, once getting the resultant, here we know the magnitude of it, and direction we can calculate the location of resultant. So since location of resultant is given by location of resultant is given by Varignon's theorem of moments, this theorem states that the sum of moments of all forces about any particular point, I will be locating my resultant with respect to 1000 Newton force. So I'll say that 1000 Newton, here I'll mark it as point A. So summation of moments of all forces about point A, summation of moments of all forces about point A will be equal to the moment of resultant, that is capital R into X. Here we will be considering all clockwise moments as positive and all anti-clockwise moments as negative. I will say therefore we will consider the first force 1000 Newton. 1000 Newton is passing through point A, so there is no vertical distance between point A and 1000 Newton force, so the moment produced by 1000 Newton would be 0. So I can write it as simply You can even neglect it, or you can just write it as 1000 into 0. It gets eliminated. Then 1500 Newton, the moment produced by 1500 Newton will be in clockwise direction at point A. So it is plus 1500 into distance, which is 1. So here I have plus 1500 into 1, then 1800. This will be producing a moment in anti-clockwise direction. So minus 1800 into 3, then 2000 Newton, which is acting downward. If I take the moment at point A, this would be in the clockwise direction. That will be 2000 into 5, then 2400. It is producing a moment in anti-clockwise direction. So minus 2400 into 7, at last 2700 Newton clockwise. So plus 2700 into 8 plus 2700 into 8 will be equal to the moment of resultant. Resultant is 1000 Newton acting downward. So somewhere in this system, resultant will be acting in the downward direction. And if it is acting in the downward direction, so the moment produced by resultant would be clockwise. I'll write it as plus r into x, and what is r? R is 1000. So if I go on calculating this will give me 0. 1500 minus 5400 plus 10,000, or 10 into 10 raised to 3 you can say, then minus, this comes out to be 16800. At last we are left with 2700 into 8, 21600, and here resultant is 1000. So if I calculate my left hand side value, this will be 1500 minus 5400. So here I will be getting this as, this answer is minus 3900, and in that if I add 10,000, that will be plus 6100. If I subtract 16,800 from that 6100, I will be getting it as negative 10,700, and in that if I add 21600, that comes out to be 10,900 is equal to, resultant is 1000 into x. So my x value will be, finally it will be, x is equal to 10900 divided by 10, which comes out to be, we can say that since here all the distances which I have taken, that would be in terms of meter, so here I can say that the answer would be, it will be equal to 10.9 meters from 10, here the force was 1000 Newton. So from 1000 Newton force, the distance x comes out to be 10.9 meters. It will be 10.9 meters, which I have calculated. So finally this becomes my second answer, and if I want to locate the resultant, I can locate it. This total distance is 1 2, that is total is 8. Resultant I am getting it as downward 1000 Newton, its location is 10.9. so 10.9 will be away from this force system. I can mark it here. This resultant is 1000 Newton, acting downward. Its location is denoted by x, and this value is 10.9 meters. So with this we have found the resultant, its direction and its location, and that completes the problem.